problem-solving strategies in mathematics. Unlike exercises, there is never a simple recipe for solving a problem. You can get better and better at solving problems both by building up your background knowledge and by simply practicing. As you solve more problems and learn how other people solve them, you learn strategies and techniques that can be useful, but no single strategy works every time. That is why today I'm gonna discuss about the different problem-solving strategies. But before starting the discussion, here are the objectives. At the end of this discussion, the students will learn the different strategies in solving math problems and apply what they have learned. So now I will discuss 5 of the solving strategies. The first one is working backwards, next is guess and test, next is solve a simpler problem, another is process of elimination, and the last one is using a variable to find the sum of a sequence. First, we focus on working backwards. This is considered a strategy in many schools. If you are given an answer and the steps that were taken to arrive at that answer, you should be able to determine the starting point. For example, Karen is thinking of a number. If you double it and subtract 7, you obtain 11. So the question is, what is Karen's number? The strategy that we will be using is working backwards. So first, we will start with the 11. So next, the opposite of subtraction is addition. Now we will add 7 to 11. It is in the given. So we are now 18. 7 plus 11 is 18. It was mentioned that the number is doubled. So we will divide the 18 into 2. So 18 divided by 2 is 9. That means that Karen's number is 9. So looking back, Karen's number, which is 9, is multiplied by 2. It's equals to 18. Then you might subtract it with 7. The answer is 11. Now let's move on to another strategy, which is guess and test. Make a guess and test to see if it satisfies the demands of the problem. If it doesn't, alter the guess appropriately and check again. Keep doing this until you find a solution. For example, Mr. Jones has a total of 25 chickens and cows on his farm. How many of each does he have if altogether there are 76 feet? So the first thing we should do is to understand the problem. We are given in the problem that there are 25 chickens and cows. Altogether, there are 76 feet. Chickens have 2 feet and cows have 4 feet. We are trying to determine how much cows and how many chickens Mr. Jones has on his farm. After understanding the problem, let's move on to devising a plan. So, we're going to use the guess and test along with making a tab. So, many times the strategy below is used with guess and test. Make a table and look for a pattern. So, make a table reflecting the data in the problem. If done in any orderly way, such as table, will often reveal patterns and relationships that suggest how the problem can be solved. So after devising a plan, we will now carry out the plan. So as you can see here, this is the table that we've made. So here you can see the chickens, cows, number of chicken feet, number of cow feet, and the total number of feet. So if the chickens are 20, the cows are 5, the number of chicken feet will be 40, the number of cow feet will be 20, so the total number of feet is 60. Next, if there are 21 chickens, 4 cows, the number of chicken feet will be 42, the number of cow feet will be 16, and the total number of feet will be 58. Notice that we are going in the wrong direction. The total number of feet is decreasing, so let's change numbers. So let's say that the chickens are 19 and the cows are 6. So the number of chicken feet is now 38 and the number of cow feet is now 24. So the total number of feet now is 62. That's better because the total number of feet are already increasing. So let's change the numbers again until we get to 76. So let's say that the chickens are 12 and the cows are 13. So the number of chicken feet now is 24 and the number of cow feet is 52. So 24 plus 52 is 76. So now we'll look back. So to check, 12 plus 13 is 25, which was mentioned that Mr. Jones has 25 chickens and cows. Now, 12 chickens is equals to 24 feet and 13 cows is equals to 52 feet, which is a total of 76 feet. So now we have found the solution to this problem. I could use this strategy when there are a limit number of possible answers and when two items are the same but they have one characteristic that is different. The next strategy is solve a simpler problem. You can use this strategy when you problem solve any situation that seemed too complicated to do in one step. In other words, it may require multiple operations or you may have to break down the problem to be able to solve it. For example, so as you can see in the figure, there are cubes. So the question is, how many cubes are there in the next step, the 10th step, and the 20th step? Here is a problem that can't be solved in one step. You can see that multiple things are being asked for in this problem. If we wanted to break this problem down into simpler steps, we could first create a table to look for a pattern. The first step has 2 cubes, the second step has 3 cubes, the third step has 4 cubes, and the fourth step has 5 cubes. Now we have simplified the problem into a table. Next, we'll look for a pattern. The number of cubes is 1 more than the step. Therefore, we could say that the step plus 1 is the number of cubes. Now it is manageable to figure out the 5th step, the 10th, and the 20th, even the numbers of cubes on the 100 step. We just add 1, so step 5 has 6 cubes, the step 10 has 11 cubes, and the step 20 has 21 cubes. The next strategy is the process of elimination. This strategy can be used when there is only one possible solution. For example, I'm thinking of a number. The number is odd. It is more than 1 but less than 100. It is greater than 20. It is less than 5 times 7. The sum of the digits is 7. It is evenly divisible by 5. So we know that it is an odd number between 1 and 100. Next, it is greater than 20 but less than 35. So 21, 23, 25, 27, 29, 31, 33, 35. These are the possibilities. Now, next is the sum of the digits is 7. So if we're to add the numbers, example, the 21, it is equals to 3, so no. 23 is equals to 5, so no. 25 is equals to 7, yes. Using the same process, we see that there are no other numbers that met this criteria. Also, as you can notice, 25 is divisible by 5. By using the strategy elimination, we have found our answer, which is the number 25. Now, for the last strategy, we will use a variable to find the sum of a sequence. So, guess strategy for sequences. which is last term is equals to fixed number multiplied to n minus 1 plus the first term. The fixed number is the amount of each term is increasing or decreasing by. N is the number of terms you have. You can use this formula to find the last term in the sequence or the number of terms you have in a sequence. For example, 2, 5, and 8. 5 the 200th term. Solution. Last term is equals to 3 multiplied to n minus 1 plus 2. As you can see, there is an n in our solution because n represents the numbered terms. So n is equals to 200. Now let's substitute. Now the equation is 3 times 200 minus 1 plus 2. 200 minus 1 is 199 multiplied by 3 is 597 plus 2 is 599, which means that the 200th term is 599. That's all. Thank you for listening.